Okay, so in this section, we are going to talk about complex numbers, what they are, things we can do with them, things of that nature. So the first thing that we need to talk about is what is a complex number? Kind of where did they come from? So to get this thought process started, we're going to start with what is the square root of 25? Now, most everybody will always say 5, and that is not an incorrect response. However, when we're asking you to find the square root of 25, what we're asking for is a number times itself gives me the value in that square root. Okay, so for example, 5 times 5 is 25. But we also have negative 5, because negative 5 times negative 5 is positive 5. Okay, just so that we have a reference here. Now, later on, we'll talk about specifics for this as to why we normally just say this one, but specifically on that later. Now, we also have the same concept, even on things that are not as pretty of an answer. So say square root of 13, there is still a 3 point something, something, something number and a negative 3 point something, something, something number that when it multiplies with itself will give you the 13. Now, mathematicians are rocking and rolling along. They're dealing with this stuff. And then they get to this, okay? Here's the concern. I can't do 5 times negative 5. That would give me the negative 25, but it won't give me, it's not the number times itself. So it's not the true definition of a square root, okay? So mathematicians were like, well, what are we going to do with this? Now, what we can do is negative 25 can be written as negative 1 to handle the negative part times 25. Now, one of the properties of square roots is that if you have multiplication under the square root, you are allowed to separate this and do the multiplication of each part with the square root on it. Okay. Now, this part, not a problem. We know it's 5 or negative 5. This became the issue. Okay. So mathematicians were like, well, every negative number could be purposed out this way, where we pull the negative 1 and the multiplication. So what are we going to do with this? So what they decided to do is they said, we're going to call this I. Okay, now I do put a tail on my eyes just so that you can tell that it is an I and not like a 1 that has a dot over or something like that. So I, by definition, is the square root of negative 1, which means when we have this, and we'll take this as just plain 5 right now, this would be I times 5. We don't traditionally write our letters first, so this would be 5i. Okay? Now, to put this into a formal definition, okay, so we've just talked about where do imaginary numbers come from. The definition is the imaginary unit I is going to be equal to the square root of negative 1. Now, the other thing here is I squared is negative 1, because if you square on both sides, square of a square root cancels out, leaving me just the negative 1. With that in mind, as we do some computations later on, if we ever have an I squared show up in a response, we will change that out to a negative 1. We do not leave I squareds in responses, okay? Now, complex numbers is the set of numbers that are in this format, A plus BI. Now, A and B can be anything they want to be. So we could have something like 2 plus 3i, 4 minus 7i. Okay, 7 is just the negative there is the negative 7. I is the imaginary unit. Now, A is called the real part. B, or the BI, is called the imaginary part. We're not creative amateurs, y'all. B has the imaginary unit on it. We're going to call it the imaginary part. A does not, so we're going to call it the real part. Now, if B is not 0, meaning that there is a BI portion, then it is called an imaginary number because it does have the imaginary part. The word complex numbers also coincides with this imaginary numbers. All of those mean the same thing. If there's only a BI, so 5i, 3i, half I, things like that, it's called a pure imaginary number because there is not a real portion of it.